I'm Ofra, and my project deals with architecture and its connection to soundscape. Our lives are always present in a sea of sound and voices. In the right architectural space, the human voice or music can be transformed in a way that can inspire faith, bring tears, and ease emotional pain. Noise is an important aspect of the quality of life in the city and in general. Therefore, we should test the consequences of extreme noise nuisance. Over 55 decibels, noise is the negative factor of the environment. And as the noise increases, the negative reaction worsens. The noise causes stress reactions, nervousness, attention problems, impaired activity in open spaces, feeling of helplessness, uncertainty, and impaired mental health. In general, noise at the high intensities cause damage to a person's health, quality of life, and harm daily activities. In recent decades, there has been a massive impact on the soundscape, which one of the most influential factors is air transport. Airplane approaches to the airport, touches down the runway, progresses to the terminal, discharges people, is refueled and refilled, taxis toward the runway, takes off, and departs to another destination. During each operation, the aircraft emits a high-intensity noise that significantly affects the soundscape. So even though over the years, the source noise has been reduced, the number of passengers and flights is steadily increasing, so that the nuisance exists and probably will not go away in the coming years. At first, I wanted to examine how the nuisance issue is tackled. From investigation conducted on the environment of airports around the world, it can be seen that there is usually a layer of land uses that serves as buffer zones. That is, a layer of uses that is not sensitive to noise, such as uncultivated land, industry, and the like. In Israel, there is not enough land to be used as a buffer zones. My project offers a new insight as the space surrounding the airport, a space that suffers from severe noise nuisance. By dismantling land uses and using architecture to address the issue of living alongside noise. In Israel, the international largest airport is Ben Gurion Airport, located in the center of the country. Zooming in, it's notable that the airport, which was established before the state declaration, nowadays is surrounded by most populated cities and towns which are constantly growing. So, despite the relatively small physical size of the airport, the range of the noise influence is extensive and affects many cities in the heart of the country. One of the cities is Or Yehuda, which is located right next to the airport and is affected by nuisance frequently, as detailed later on. In an environment where many people suffer from high noise level, there is a regulation aimed at preventing or reducing the impact of the annoyance. In Israel, the regulation refers to areas affected by aircraft noise and defines the following conditions. Restricting the locations of sensitive land uses, preventing approval of new noise-sensitive construction, requiring an acoustic insulation in bedrooms. All the regulation solutions are related to the interior only. Hence, the question arises, what about the outer spaces, the spaces held by buildings? The outer spaces, the open spaces which buildings define, have been forgotten. Imagine a child living in the city of Or Yehuda, and not during the COVID-19 times, leaving the housing building close to the noise a lone owner or a busy commercial area. By being outdoors, you are supplied by unpredictable and unseen noise. In fact, there is a lack of any holistic view on the issue. There may be a situation where our two neighboring buildings, one of which is eligible for acoustic protection and the other is not. And as we have seen, open spaces will not be entitled for any protection. Hence, the main question is, how can neighborhoods and buildings be designed to reduce the negative effects of extreme noise nuisance? In order to answer the question, I examined acoustic principles for urban and building scale. I will review them shortly. The underlying acoustic principle is the acoustic shadow. Acoustic shadow is an area created behind noise barrier where is a blockage of the direct path between the source noise and the receiver. The barrier can be natural, artificial, or the combination of the two. The second principle is the building envelope in reference to the noise source, which aims to create protection for the open space near the building and prevent secondary sound repeats. The principle of construction height refers to the building's height, aiming to provide acoustic shade and prevent sound resonance. The principle of design facade geometry aims to use geometric changes in the facade in reference to the noise source. It can also occur in a smaller scale. As I mentioned earlier, limiting sensitive land use planning and planning them according to the source of the noise. Sensitive land use refers to residents, educational institutions, nursing home, and the like. The fifth principle is construction materials, which refers to how it affects the acoustic environment. There is no planning strategy that incorporates the different principles. Hence, my research proposes a soundscape urban planning strategy. I will shortly go through the strategy as detailed by set of methods presented from the urban scale to the building. Acoustic urban grid, adjusting the urban grid parallel to the noise source direction to increase the potential of the acoustic barrier. Land use classification, one scale, the urban, land use planning with reference to the noise source. And the second scale, a mixed-use building where one use can protect the other. Acoustic construction characteristics, use of the building envelope to prevent echoing and reverberations. The last stage, the acoustic building facade method, use of materials and directing of building facades in accordance to the noise source. And these are the full method working set. As I mentioned earlier, the project focuses on the city of Or Yehuda. I will present it from the urban to the building scale. You can see Ben Gurion Airport and the city of Or Yehuda, and I will focus on the Asirei Tzion neighborhood, as the distance of the flight path ranges from only 2 to 500 meters. According to noise contours taken from the airport national outline plan, the residents suffer from noise nuisance constantly. The criteria measurement is LDN. In general, it's the average sound level over a 24-hour period. In addition, there is a safety restriction which limits the construction height. So even though a desired acoustic barrier scheme should look like this, in practice, as a result of the height limits, the principal implementation is weakened. Today, the neighborhood contains about 130 housing units. And according to the municipality future planning, it will increase to 1,500 to almost 2,000 units, where the noise nuisance continues to be significant. According to a simulation done by using 3D noise software. Now, I'd like to take you through the soundscape planning architecture strategy implementation. I will begin at the urban scale. This is the planning site, the Asirei Tzion neighborhood. In the neighborhood already exists the mall, a large public open space, educational and cultural institutes, and offices. At first, we should apply the acoustic grid method. This is the basic acoustic urban grid on the site. At its present neighborhood, with existing grid of streets and roads, there is a need to adapt to and combine two grids. The combination of the grid produces a new planning system in the neighborhood, containing open spaces for useful, protected, green urban areas. Suggested plan is designed under the noise limits, no build of noise-sensitive uses under LDN 70 line. Accordingly, no sensitive land use, such as offices, are planned south to LDN line. Schematic master plan designed according to the height limits and by maximizing the acoustic shadow. Examining the planning scheme using 3D noise software, it is notable that the suggested scheme is more efficiently noise protected. It should be stated that the test results based upon the 3D noise software are rough, since the existing tools do not address to architects. Therefore, an architecture fit software for soundscape performance is needed, such as the Ladybug for sunshades. So comparing the current planned and suggested scheme of street or playground, it shows that the only suggested design addresses the noise nuisance and offers different design. The street offers noise protected path, and the building surrounding the playground contains its noise. And more different city situations that can be successfully architecture designed with a challenging soundscape. We can also choose to embrace the unique urban experience instead of ignore the challenge or snuggle from it. So what is the experience in a soundscape architecture design place? It requires different building layout, considering the noise source direction, trying to prevent echoing and reverberations. Allows for wandering in a quiet path with connection to the city, and offers noise-protected open spaces. Now, we will move on to the scale of the building, designed by the same soundscape planning strategy, chosen to its location next to offices, residents, between noise and city grids, new and old parks. The process begins with a given plot, then raising desired or possible building height, planning the protected open space for achieving building boundaries. Then classify its facade according to the noise-sensitive use, and afterwards adjusting building heights according to the source direction and its facade angles. Then consider additional factors as climate. According to the planning strategy, adapt facade materials, combine different materials to create ventilation contact with the exterior, such as glass, which creates sound reflections, plus absorbent materials that can prevent unnecessary sound repetitions. All this for the design of noise-sensitive building. In the building articulation, I try to consider the noise produced by different programs as well. Thus, the building incorporates a hybrid design according to the noise source, containing open spaces, offices, residence, commerce, and public uses, for the purpose of protecting the sensitive uses both inside and outside the building, to create a noise-protected open space while connecting with the ground floor, existing Milwaukee Park, and street lives. The building is designed according to the soundscape strategy, enables new interface between offices and residents, offering a special floor plan that creates shared spaces to add protection to the residential areas. In this special floor, the planned residences are relatively small housing units for younger population who can work and live in the same space while sharing lives with the building and with the city. When on the typical building floors, where apartments are designed for small families, it is possible to create a separation between the uses for privacy, while gaining the noise protection from the office part. The office facade is designed differently than what we are used to, which are facade of curtain walls, since they are not suitable for construction alongside noise nuisance due to its reflection created using glass. Instead, absorbent material were used to prevent some of the sound reflections, so that the purpose of hiding the glass and preventing a parallel facade that can produce a lot of resonance, the facade was designed as a system of faults. Thus, creating a place and a path for office users who can also need a quiet rest outside. Entering the building is through a quiet path connecting the quiet open space to the build. On the ground floor, additional programs are planned that may affect the building internal soundscape, such as the gym and the kindergarten, where the noisy spaces of these programs are planned underground, but allow access to the internal open space and exit to Milwaukee Park and the city. At the same time, the open space design allows urban life, which is protected from the aircraft noise, and when producing noise of its own, it's done consciously. In the residential areas, the facade is planned as a non-uniform facade, which produces sound diffusion through build shifting in order to prevent the reverberation in the inner courtyard. Thus, different and varied envelope building sections designed to break the corresponding facade cross-section. This technique is also implemented in a smaller scale, such as in windows opening that are slightly inwards, in order to produce an absorbent envelope, which will prevent some of the reflection formed by the glass. By implementing the sound planning strategy, we can create a quality of life next to a noise nuisance. In a noisy modern life, there is a great importance to consider the noise landscape. I think it's essential to raise awareness to the soundscape aspect in the architectural design process. תודה.